Okay guys, today we're talking about locked timeouts and correlating them with the owning query, the query that's actually suffering the locked timeouts. This is from a blog I wrote and published January 7th on midnightdba.com. It's got a little bit more information for you, so like here I'm going to go ahead and skip over a little bit about the server-side trace and saving it as a table and all, but you should know that for your trace, be sure to get the RPC starting and completed events, all columns, and the locked timeout greater than 0, because we're gonna need those events to be able to correlate them together. By default, the profiler trace, the standard profiler trace, will get RPC completed for you, but if you have locked timeouts, it's entirely possible that your query will have timed out, and so you will only have the RPC starting. So go ahead and get that. So I've already done that. Yay. It's like a cooking show. I already have a completed cake right here for you, and we've got some of our data in a table that I can, right here on my home box, not on the server, so that I can play around with it and analyze. The data is displayed, the event class is displayed by number, not by the name of it, so you don't see RPC starting here and locked timeout here. 11 is RPC starting, 10 is completed, and 189 is locked timeout greater than 0. Let's see. So if we were going to correlate a locked timeout by hand, then we would go through and take a look at our data and see, okay, where is an event 189? I'm down here, and oh, there's one. So now that we've found one by hand, we can go back up and find one, and our criteria is that it has to be, let me select this whole row so we can scroll over, that it has to be of the same SPID, and luckily here we're all SPID 53, so it works out, and it's the most recent event, what did I say, is starting, 11. So there we go. We've just manually correlated the lock timeout to the code that was holding the lock that timed out. Yay! But we don't want to do this 40,000 times by hand, and we don't. You know, that's the joy of databases. We can do this automated, and we can group, and we can see how many times that this stored procedure timed out, and so forth. So that's what we're doing. We're developing that query. Yay! First, part one then would be finding the timeout, which is easy enough. Select from trace where event class equals 189. And I've got top 10 here just for the purposes of, you know, when I'm going through and either developing this query or after it's done, looking at the timeouts and queries themselves. I don't want to look at 1,000 at once, so you can change top 10 or remove it or what have you. So the next step is figuring out the closest, the most recent row before that, row number is less than the timeout row number, where the SPIDs are the same. And that kind of immediately says, well, aren't we talking about a cursor? Because for each timeout class, you want the most recent. No, don't go with the cursor right away. What it says to me is a correlated subquery, because that's the exact one of the big things you can use correlated subqueries for. In a correlated subquery, you've got the outer portion, which goes through and gets, say, your timeouts, and then says, okay, for each one of these, I'm going to match up to an inner query, and the inner query would say, well, let's see, row number less than the timeout row number, SPID less than the timeout SPID, and we'll go ahead and be specific and say, you know, database IDs are the same and so forth. So for our inner query, well, let's just develop it by picking one of these guys. This row number right here, 147, and SPID is 53, and just develop this little subquery. So select the top 1 star from trace with the same SPID that's less than our timeout row number with the same event class. And here I sound like Clue. It's Mr. Green in the washroom with the toilet paper roll. So there we go. We've found the code programmatically that goes with the timeout we just found. Now to put them together, we copy this jobby over here, our outer query and our subquery, and then we've got to make this correlated. So I'll copy it. We'll put it over here. So here's our outer query, right? I've changed our select to have our timeout information and then our statement information. So we're selecting from trace as timeout, inner joining to itself as statements, where the SPIDs are the same. Somehow, for some reason, I've got that twice, and I think I did that in the blog too. I should correct that. The databases IDs are the same, and the statement row number is equal to, and here's where the row number for our statement. And you'll recognize this as being extremely similar to our little query that we just developed by hand. So select top 1 star from trace, where SPID equals the timeout SPID. We're correlating again to this up here. Row number is less than 147. Row number is less than the timeout SPID, right? And event class is 11. That's RPC starting. Now we're ordering by row number descending. That means the biggest numbers at the top, because again, we want the most recent, the closest one to preceding the timeout row number. And this should work absolutely beautifully. Ta-da! That didn't work. Oh, yes, it did. I'm sorry. Because it's all in a line. We've got our timeout row number, event class, and so forth. And then we've got our statement row number, event class, and so forth. This is great, but I like to clean things up visually a little bit because I hate having to go, oh, okay, there's my statement information. So taking the same thing and jumping over here, instead of using statement.star, I like a couple of things. I like to say what specific info I want from statement, and I like to put a spacer in between, and I'll just show you how pretty that can be. So we go, there's our timeout information, la-di-da. Ooh, look, here's our statement information. It's a little trick. You're welcome. It's all good. One of the other things that you should probably do, if you're going to be doing this and playing around with it a lot, before you take this query and plug it in and find all your information, is make a couple of indexes. And if I can go off on an indexing tangent real quick, you might want to go ahead and create a couple of indexes, which I have conveniently placed on the blog for you. Because you may be going through tens or even hundreds of thousands of rows of data on your from your trace, and indexes make things faster. So, oh, I was going to compare, I'm sorry. So without the traces, we can get our execution plan and take a quick look and say, wow, looky there, we're doing table scans, and you know, it's going to take a long time. And with a couple of, I probably don't need to preach to you about the joys and value of indexes, but it's not going to stop me. So so here's our execution plan once we've applied our indexes, and it's a lot better. Index seek, index seek, index seek. And there's an RID lookup, which, okay, so that's not good, and I could change that, but I'm not going to today. So consider that your homework. If you need to use this, then make better indexes and email me and tell me how I should have done this myself. So, but that's all we've got today. Hope this was helpful. There are other applications for this correlation statement, but really that's a future blog. So good luck, happy hunting, and there you go.